When we look at rational functions, we're going to need to talk about asymptotes also. Here's the equation of the parent graph, y equals 1 over x. The first thing we need to notice is that there's restrictions for values because some values of x or y will make this function undefined. Since x is in the denominator, x can't be 0. That would be undefined. And since the numerator is a value without a variable, there's no way to make y equal to 0 either. If you're not sure why this is true, one thing you can do is plug in 0 for y and solve for x. If we do that, we can cross multiply. 0 times x is 0, but 1 times 1 is 1, and that's not true. So we can't solve for x when y is 0. So we have two restricted values. X can't be 0 and y can't be 0. The effect on the graph is called an asymptote. Let's draw the graph. Okay, let's see how those two restrictions affect the graph. If x can't be 0, that means there are no points with x coordinates of 0. And so what we do is we draw a dotted line right through x equals 0 to show that there are no points there. That's called an asymptote. So there's an asymptote at x equals 0. There's also one at y equals 0, which is the x-axis. So there aren't any points here where their y-coordinate would be 0. That's the other asymptote. So we have what we call a vertical asymptote and a horizontal asymptote. Now let's plug in some values and see what happens to the graph. We already know that x and y can't be 0, so there's no intercepts. Let's try a few negative numbers, like what happens when x is negative 2. Y equals 1 over negative 2, so we get negative 1/2. And when x is negative 1, we get negative 1. When it's positive 1, we have 1. Positive 2 makes 1/2. That's not really enough points, but let's see what we have so far. Negative 2 down 1/2, and negative 1, negative 1. Now I want to know what happens in both directions from here before I jump over that asymptote. So let's go ahead and plug in negative 3, and I get negative 1/3, so even closer to the y-axis, or the x-axis, excuse me. Got a little point right there. Now you might think that it's about to run into it, so let's pick something way out there, like negative 10 is kind of out there, right? And we get negative 1/10, which is even closer. It's just hard to graph on graph paper this small. But what we get is that these points are getting closer and closer and closer to that asymptote. They never touch it, they never cross it, but there's always some numerical distance between the point and the x-axis, and it's getting closer and closer and closer. If we had graph paper that was huge, or a scale that was really big, then we could show it getting closer and closer for a longer distance. In the other direction, what happens is, if we plug in something closer to the y-axis, like negative 1/2, it's the reciprocal of that, so it's negative 2. So at negative 1/2, it's dropping, it's got a bigger jump going on. And then at negative 4, or negative 1/4, it would be 4. So it's getting closer and closer. It's a curve that is trapped between these asymptotes. It's sort of stuck in the corner there. And what it's going to do is it's going to trend towards the asymptote but never touch it, never cross it, just like that. On the other side, what we have with the positive numbers is we have a point at 1, 1, and we have a point at 2, 1/2. And then if we plug in more points like 1/2, we get the reciprocal of that is 2. So we see the same trend, but over here in quadrant 1. It's going to get closer and closer in both directions, like that. And that is the general graph of rational functions. Okay, let's get it more complicated. So instead of just 1 over x, how about 1 over x plus 2? In this case, our h and our k for shifts are located like this. X minus h is the denominator. If there's a k, it's over here. So in this case, this is the opposite of the horizontal shift. So the shift is -2. Well, what does that mean for this kind of graph? Let's see. Okay, if there's a horizontal shift of -2, notice that now what value would make this equal to 1 over 0? -2, right? So now x can't be -2. That is the new location of the asymptote at -2 on the x-axis. So here's -2. We've got a vertical asymptote going right through there. Okay, do we have a horizontal asymptote? Well, let's see. In this case, can y be 0? No, y can't ever be 0 because the numerator is 1. There's no way to get 0 for a numerator of this fraction, and that's the only way to get a fraction equal to 0. So we still have a situation where y cannot be equal to 0. So we have a horizontal asymptote right across the x-axis still at y equals 0. Okay, our curve looks just like the previous curve. It's just that the asymptotes have shifted over. So the curve is going to be more like here and here. Smooth that out a little bit. So there's our curve. Let's try another example. How about y equals 1 over x minus 5 and then add a 3 over here? What does that do? Okay, so now the value that x cannot be is whatever makes that denominator equal to 0. So you should be thinking, when is this going to happen? That's going to happen at x equals 5, which means x can't be equal to 5 in this situation, okay? That means there's going to be a vertical asymptote through x equals 5. What about y? Now we've got a shift of +3. Well, if you subtract that to the other side, we get y minus 3 is equal to 1 over x minus 5. Okay, and we know that this fraction cannot be made to be equal to 0. The only y value that would make this side equal to 0 would be y equals 3. So we cannot have y equals 3 in this case. So let's look at the graph. So at x equals 5, we've got a vertical asymptote like that. And at y equals 3, we've got a horizontal asymptote. Okay, that shifts our graph. So now our curves are located here and here. Notice the shape is the same because we don't have a multiplier, and the quadrants haven't changed because we don't have a negative multiplier. By quadrants, I mean with respect to the asymptotes. So now let's talk about domain and range for these functions. In the first example on this page, the domain is everywhere except where that vertical asymptote is. So we can say that the domain is all reals as long as x is not equal to -2. And the range has an asymptote at 3. And the range can be all reals as long as y is not equal to 0. Because we can see that this graph is going to go on forever towards infinity and negative infinity on the horizontal axis as well as the vertical axis. It's just that that one location is never going to have a point. Okay, similarly over here, we've got domain is going to be all reals except that x value that can't occur. And the range is going to be all reals except where y is equal to 3. And that should get you started graphing rational equations.